Hello everyone, welcome to a new video. This will be a quick video because I am recording this video in a break time of our training session in the company. So let's quickly see the problem of the day given. Water the plants. Let's see the problem statement. A gallery with plant is divided into n parts, numbered from 0 to n minus 1. There are provisions for attaching water sprinklers in every division. A sprinkler with range x at division I can water all the division from I minus x to I plus x. So we are given with an array gallery consisting of n integers, where gallery I is the range of the sprinkler at partition I. And it is given that a power of minus 1 indicates no sprinkler is attached, thus it will not water any part of the gallery, and return the minimum number of sprinkler that is needed to be turned on to water the entire gallery. And at last, if there is no possible way to water the full length using the given sprinkler, we have to return minus 1. So let's understand what we have to do in this problem. This is our given input. So according to the question, we have to water a gallery of length 6. We can consider it as a length of 6. And every element present in the gallery array is the range of a sprinkler that it can water. So let's see the first element. This is given as minus 1, and according to the question we have seen that minus 1 means there is no sprinkler attached, and hence it cannot water any part of the gallery, so we will not consider it. See the next element of the gallery, it is 2. That means according to the question it can water up to I minus 2 index to I plus 2. This is what it is stated in our problem statement. So I minus 2, what is I? I is 1, which is the current index value. So 1 minus 2, it gives minus 1. Thus it can water up to minus 1 index. That means here. But we are worried about this index, that is 0th index, because we have to cover the area from this index to the last index, that is from 0 to 5. But if this sprinkler, that is what present in the first index of our array, can water up to minus 1 index, that means it can water from the starting of the gallery. It can water up from the starting of the gallery, and now we have to consider the endpoint also, till how much it can water. So that will be calculated by this formula I plus 2. So we will add our index value, that is 1, with the current value of the array, that is 2. So up to 3, up to third index it can water in the right side. So this is our third index, right? So the sprinkler present at the first index will water from the starting position till the third index of the given array. And accordingly, we have to find the minimum number of sprinkler that is needed to water whole this gallery, that is from 0 to 5th index. So as we have to find the minimum number of sprinkler, I hope you have guessed it right. We have to use a greedy approach to solve this problem. But before getting into the approach, let's see the other elements present in our gallery array. So the next index is 2. So the range of next sprinkler is 2. That is 2 for the left side and 2 for the right side as well. So if you want to calculate it again, you have to subtract the index value from the given value, that is 2. So it will start watering from the 0th index. That means the left range is 0. It will start from 0 and it can water up to 2 plus 2. That is the index value plus the given value, that is 4. The fourth index of our array or the gallery. So it will water up to this index, right? So we can see it can water starting from 0th index till the 4th index. So it covers more area than the previous sprinkler. I hope this is clear. It's very basic thing. As because we have to find the minimum number of sprinklers, so we have to find such sprinkler that covers maximum area. Thus we will consider this over the previous sprinkler. Now let's see the element of the next index, that is minus 1. That means it will not water. It is not open. The sprinkler is not open, thus it will not water. So we will iterate to the next index of the gallery and it is 0. So what does 0 represents? Let's see. The index value I is 4 and the value given is 0. So the range is 4. That means it will water only this index of the gallery. Only one index of the gallery. That is the fourth index of the gallery. But if we use the previous sprinkler, we are already watering that index. Using the one sprinkler, we can water that. So we will not consider it, right? So till now, after iterating all these 4 elements of the gallery array, we have seen the max end is the maximum range our second sprinkler is covering. Thus, we will consider this sprinkler and this sprinkler is needed to be turned on. So it will water from the 0th index till the 4th index, which is the maximum end till now we have got. So what will be the count till now? It will be 1. because we have opened this step or this sprinkler. Yeah. So next we have to water the last index of the given gallery. So for that we have an element 0, or we have a sprinkler that range is 0. So let's calculate. 0 basically represent it will water to this index only, to itself only. But let's calculate it. So the left range will be index value, that is 5 minus 0, that will give 5. Thus it will start watering from the fifth index, and the right index will be I plus the value itself, that is 5. So it will start watering from fifth index and end in the fifth index. Thus we will water this part also, this part of the gallery also. Thus we can consider this, right? Because none of the sprinkler can cover this last index, so we have to consider this. So now if we consider this, our count will become 1. The number of sprinkler we need to water the whole gallery becomes 2, and this is the minimum, right? This is the minimum number of sprinkler. Thus we will return 2, and in the answer we can see the output is 2. Yeah. So you can see the explanation. The sprinkler at index 2, that is this one, and the fifth sprinkler, that is this, can water the full gallery. The span of the sprinkler at index 2 is 0 to 4. That is, it will water the left 2 index and the right 2 indexes as well. And our fifth sprinkler will water to itself. Thus this is all about the question. I hope you understand this question with the help of this example. Now let's see what will be our approach to solve this question. So basically, we have to consider the ranges, that is the left range and the right range of every sprinkler. So we will consider a sprinkler which has a minimum starting point and a maximum ending point. So first of all, we will find the starting point of all the sprinklers, and by these starting points we need to prioritize the minimum starting index, because to cover the largest area in the left side with the minimum use of sprinkler, we have to take, or we have to choose a sprinkler which can water up to the minimum index in our left side. So what I mean by this, actually, if we have a sprinkler which will water up to the first index, and we have another sprinkler which will water up to the minimum index, that is 0. In this case the minimum index is 0. So to cover the max area using minimum number of sprinkler, what you will choose? We will have to choose this sprinkler. So that's why we will prioritize the sprinkler whose starting point is minimum. And in the same way, how we will cover the maximum area on the right side? Can you guess it? It is simple, right? The sprinkler which will go up to the maximum range on the right side will cover the most area. It is a basic thing. So in the left side, we need to find the minimum index, and in the right side, we need to find the maximum range or maximum end. So we have to consider both things. Thus, we need to store these values, right? The starting index and the ending index in the array. So we will create a 2D array. This array will contain n number of rows. In our case, we have n equals to 6. So we will create 6 rows, right? And we will create 2 columns. The first column will indicate the starting range, and the second column will indicate the ending range, or it will store the ending ranges of each of these sprinklers. So our first is -1. That means the sprinkler is not open, thus it can't water any part of the gallery. So it will be simply 0. It will remain 0. And in the second iteration, the value of the gallery array is 2. Thus the range is 2. So we have to find the minimum index for this sprinkler, until that it can water. So to find the minimum index, at least it should water till 0, because we have to water the gallery from starting from the 0th index, right? So we will simply write I, that is the index value, minus the gallery of I, the value in present in our gallery array. So this will give our starting index, right? Maximum between 0 and the value or the range up till it can water in the left side. So why we are taking the max? Because we don't care about the negative indexes, right? We do not care about these negative indexes. We just have to water from the starting point of the gallery, which is 0, 0th index. So we will take the maximum between the 0 and the left range of our present sprinkler. So in the first case, we have found it -1. The left range was -1, but we have to take the maximum between 0 and -1. So we will take 0. And similarly, we have to find the ending range, which gonna be the maximum. That is the ending range. So at most, in this given example, our range can be 6, because the value of gallery, or the size of the gallery is 6. So at most we can water up to 6. So we will find a minimum value between our range given, that is n-1, and the right range, which is given in the problem statement. How to find I plus 2? That means I plus value of that sprinkler, or the range of that sprinkler. By this we can get up till which index our sprinkler will going to water. So for this sprinkler that is present in our first index, the ending range will be minimum between n-1, which is 5, and the right range of this sprinkler, that was, we have calculated it, right? That was 3. So the minimum is 3. That is, it will cover up till the third index. So we will write the right range also. And similarly, we will calculate all the starting range and ending range for all the sprinklers given in our gallery using these formulas. So let's write it 0, 4, 0, 0, 4, 4, and 5, 5. You can check this, right? The first will not water any of the part of the gallery. The second sprinkler will water for minimum from 0th index till the third index. The next will water from 0 till the fourth index. Next is -1, so we got 0, 0. It will not water any part of the gallery. Next is 4, 4. That means it will water to itself only. And the last one is also 5, 5. That means it will water to that particular index only. So we have got this 2D array where we have stored the starting range of each sprinkler with the ending range of each sprinkler. Now we have discussed we need a minimum starting range to maximize the coverage at the left side. We have discussed it, right? So to get the minimum starting range out of all these ranges, what we have to do, we will sort our array based on the starting ranges. But in this example, we can see our array is already sorted. So we will basically jump into the next step. That is, we have to consider the max end now. The sprinkler that waters up to the maximum range covers the more area at the right side. So we have to consider the right side this now. So for this, we will take a priority queue and store all the max end of each sprinkler, which also covers the minimum starting point to water. So to store this ending range of each of the sprinkler, we need a priority queue. So we will take a priority queue to store the maximum end of each of the sprinkler. That means up till how it can water each of the sprinkler, considering the minimum starting range. We have to consider that. So we will basically initialize a starting range, right? We will initialize a starting range as 0. That will be our starting range. This is our starting range till where we have to water in left region of our gallery. So the starting range will start from 0, and and now we will check all the starting points of the sprinkler. So at first we can see the starting range of a sprinkler is 0 and the ending range is also 0. That means it will not water. So we will iterate to the next starting range. That was 0, means it started watering from the 0th index till the third index of the gallery. So in the priority queue, we will add this value, the ending index or the max end till which a sprinkler can water. So in a priority queue, we will add this, and then we iterate to the next index. Again, we saw that it is covering the starting point. That is, it is watering the starting point and will water up till the fourth index, which is the next max end, right? So we will add this value also in our priority queue. But in a priority queue, we will not add values like this, the end values like this, because we need the maximum value. And if we take the value present in our front, in this case, we will get the minimum one, right? So to consider the maximum end range, we will store the values in a descending order in our priority queue. So for that reason, 4 will be our front of the priority queue, and then we will add 3. And now in the next iteration, we get the starting range is 0 and the ending range is also 0. That means it will not water any of the index. In the next iteration, we get the starting range as 4. But our starting is 0, right? So we have to start watering from the 0th index. But here our starting range itself is 4. So it can't water the 0th index. Hence we will not consider these two. Because this is also 5. It can't water the 0th index. So we can see our final priority queue is this. And now we will take the maximum range or the maximum ending range up till where a sprinkler can water. That is present in the front of the priority queue. That is 4. So basically we got our first sprinkler which will water up to the fourth index starting from the 0th index, because our start was 0. So from starting index till the fourth index, our sprinkler will water. So we are left with the last index and we have to iterate further, right, to calculate that. So we will pull out this value from our priority queue, that is up till what we have watered till now using the second sprinkler of our gallery, and we will add 1 to it. So we came to this index of our gallery, and now we will perform the same operation for this index, and if the gallery contains more number of sprinklers, we will continue the same operation. And after each such iteration, that is from the starting range till the ending range, we will check whether our priority queue contains any element or not. If it contains, that means it has watered the part from the starting range till the ending maximum ending range, and thus we will update our count, right? So in this case we have values in our priority queue, so we will update our count by 1. In the next iteration, our start will be this index, that is 4 plus 1 5. Our start will be fifth index. Now we will perform the same operation over this index because it is the last index, so we have to perform for this index only, and we will check if it is watering the starting index, that is 5. Yes, the starting range is 5 of this sprinkler up to the right range, that is the fifth index only. So we found that it can water our desired index of the gallery. So we will add this again in our priority queue. And as I have discussed, we have to store the max end in a decreasing order to get the maximum right range. That is why 5 will come in the front of the queue and 3 will come here. And now we will pop out this value and our start will become 5 plus 1, that is 6. But we have no such index in our array. Our array contains 6 elements, 0 to 5. So we will stop our iteration over this. And in this case also we have some values in our priority queue. So our counter will increase by 1. Hence the number of sprinklers become 2. So this is all about the explanation. This is how we have to approach this problem. Now let's get into the code quickly. I've written the code already to make this video short. So we have done the same things which we have discussed. We have taken a 2D array. Then we have filled the first column of our 2D array with the starting range of each sprinkler, and the second column or the first column, because it is zero base indexing, the first column of our 2D array is filled with the ending range of each sprinkler. This is what we have discussed. And for every value of -1, we will simply ignore it because these sprinklers are not working. And in the next step, we have sorted our 2D array using our own logic. The logic was we have to sort the 2D array based on the starting index to maximize the area coverage in the left side of the gallery. So I have uploaded a detailed video on comparator, and you can see the link here in the I button. You can check it out. But if you are familiar with this concept, so we have sorted our array based on the starting index of all the sprinklers, and then we have taken a priority queue which will contain all the ending points or the ending range in a descending order. We have sorted it in an ascending order, and then if we reverse the array we will get a descending order. So why we are reversing this? The basic idea was, I told that already, that we need to find the maximum range, and if we reverse it then only we will get the maximum in our front. And in the queue, basically the dequeue operation performs from the front index of our queue, so that's why we have to maintain this priority queue in a reverse order or a descending order. So we have done that. We have taken a priority queue which will take an integer, that is the max end of each sprinkler. Then we have a starting range, that is 0, because we have to start watering from the 0th index of our gallery. And then we have a variable count we have taken as sprinkler. This will calculate the total number of sprinkler needed. Then we have started a while loop. This loop will start iterating from the start index, from where we have to start watering, till the last index, because we have to cover the whole gallery, right? So till the nth index, last index, we will iterate. And then we are checking the starting index in the first column. See, this is I comma 0, that is the first column. The starting index value is less than or equals to start. So if the starting index is less than or equals to start, that means it is covering that index, right? That is watering this index. So we will simply enqueue this sprinkler in our priority queue, and our comparator dot reverse order will make sure that the order remains same, that is all the max end enters into the priority queue in a descending order, and then we will iterate to the next index of the gallery. So this is how we are calculating all the ending values for each of the sprinkler, which will cover from the starting point of the gallery till the max end region in the right part of the gallery or the right part of a particular sprinkler. And then when we are done with calculating with the maximum ranges, all the values are stored in a priority queue. Then we will check whether our priority queue is 0 or empty or not. If the priority queue is empty, that means there is no such sprinkler that covers the area starting from the starting index. So in that case, we will simply return 1. That was mentioned in our question. We have to return -1 if there is no possible ways. And if it is not, that is we have some values in our priority queue. So in that case, we will increase our counter. That means we will turn on a sprinkler, and our start will be updated by the next index. So this thing we have discussed it, right? If we poll the max end, we will get the maximum range a sprinkler can water, and then if we add 1, that means we are going to the next iteration. This will be our starting point now, and we have to find a sprinkler which can start watering from this index, this particular updated index, till the last of our array. And thus, after iterating till the end of our gallery array, we will simply return the count of our sprinkler. This was all about the code and the program. Let's quickly compile and run our code. So compilation completed. Let's submit our code. Yeah, so it has passed all the possible test cases given. If you found this video helpful, please like, share and subscribe this channel, and let's get back with another video tomorrow. Till then, happy coding.